Ladies and gentlemen, welcome to Australian FameLab National Finals 2023. Woo! My name is Dr. Jacob Martin and I will be your MC for this evening. But let me introduce you to Irene Stainton, respected Noongar elder, to present our welcome to country. And she's just mentioned recently she's been inducted into the Australian Order. So welcome her to the stage.
Blinded by the light. Oh. He wasn't meant to mention that. I wanted to sort of sneak in as an elder and sneak out again, but obviously that's not an option. Kaya, wanju, greetings and welcome. Elders, countrymen, ladies and gentlemen, and especially welcome to our online viewers. Before I get into the welcome, I want to share a little story about this place. For me, it's very much home. I can't see any of you. I'm so sorry. I cannot engage because the room's too dark. I used to sneak into this building. I worked across the road at Trades Hall. I was 15, and I'd walk down here to go and do the banking for the union that I worked for. And I'd sneak in here, and I'd stare around in awe at all these books. And I was a trustee when we were doing the redesign and all of the work that's been done. I'm so very, very proud of this place and the work that we've achieved. But one of the main things that I wanted to have here were those spiral staircases. I used to sneak up there. I used to be tiny. And I used to sneak up the spiral staircases and, like I said, in awe and amazement about all these wonderful books. So now I'll get into the welcome, now that I've shared my little bit about this place. I'm pleased to welcome you to this location this evening, as we're surrounded by heritage places which are significant to my people, and I'm especially proud to be welcoming you to the Western Australian Museum, Boola, Bardip. Many stories, and I guess you can hear in my voice how I'm passionate about this place. Firstly, I must acknowledge the creation story of the Waggle and the Derbil Yerrigan, which is now known as the Swan River. Our Waggle dreaming teaches us about the creation of the river, how the bends were made, including where the Waggle laid eggs upriver near Bell's Rapids, then travelled south to shed its scales. It rested in the cool deep water near the old Swan Brewery and continued on to the Waggle Cave in North Fremantle, where another rest was taken before moving on to the ocean and up to Two Rocks. In terms of Two Rocks, there is an associated creation story about two children disturbing a meeting of elders at Orchestra Shell Cave in Nirrumbuk. The young people were removed from the meeting to another location, and when the tide rose, they became trapped in the ocean, turned to limestone, hence the name Two Rocks. There are many local important places within my run, which include right here where we meet this evening. It was a wetland and a food source. Other heritage places include under the Bunbury Railway Bridge, which was known as the Hotel of Stars, and along the reed-covered banks of the Derbil Yerrigan near the East Perth Powerhouse and Claysbrook. These areas were well-known camping places and were used as such up until the mid-1980s, as there was plenty of food and access to fresh water. There was an ochre source near the Perth Rail Terminal, which was used for ceremonial purposes, and the Windan Bridge, which crosses the river, was named by local Noongar elders as a mark of respect for the rich heritage value of East Perth, and to acknowledge traditional leader Yalagonga's wife, Windan. Finally, in welcoming you this evening, I'd like to remind us all to think about the importance of this traditional practice, and that once welcomed to country, you are invited to fish and to hunt and to share our waterholes. But most importantly, being welcomed is about keeping you safe during your visit to Noongar land. And this message is especially important from visitors who may be here from other locations. That in the event of a severe mishap, your spirit will be culturally safe and most welcome in this place prior to entering its streaming, Wanju, Wanju, Nanakaba, Nanjababuja, welcome all of you to my land. And before I sit, I just want to take the opportunity to wish all of you the absolute very best and to thank all of these amazing, incredible minds that we have in this room. You're our future. You are the people that solve all of the things that need to be solved down the track. You have the patience and the tenacity, and you are just brilliant. And for me, you all have my utmost respect.
Thank you so much, Irene, for that incredible welcome to country. And thank you so much for your tireless work getting this place here. It just feels so special to have you here to welcome us to it. And I would like to, on behalf of the foundation of the WA Museum, I'd like to extend a warm welcome to you all and to our distinguished guests, the Honourable Stephen Dawson, MLC, Minister for Emergency Services, Innovation and the Digital Economy, Science, Medical Research, Minister assisting the Minister for State and Industry Development, Jobs and Trade, Tonya McCusker and Malcolm McCusker from the McCusker Charitable Foundation, Professor Melinda Fitzgerald, Deputy Vice-Chancellor Research, Curtin University, Professor Peter Eastwood, Deputy Vice-Chancellor Research and Education, Murdoch University, Alec Cole, OBE, CEO, WA Museum, Professor James R. Vanatakis, Director, Forest Research Foundation, and Professor Lynn Beasley, former Chief Scientist for Western Australia. And shortly, it will be my honour to introduce you to the 12 best up-and-coming voices in science communication in the country. Researchers from around Australia who aren't just seeking solutions to our problems and working on improving our lives, but they are here to tell us about their work and their passion. But I'd like to set the scene for tonight as well as explain why, as a scientist, I am so excited about FameLab, and also to explain why I have this. You wondered. All right, so FameLab is all about communication, but it's also about props, okay? Props are very important, and so I thought I would bring my favourite molecule to the stage. So this here is C60, isn't it cute? It's the soccer ball molecule. And there's many reasons I love FameLab apart from the amazing props. Just toss that over there. There we go. Oh, it's a molecule, 60 carbon atoms assembled in an icosahedron. Anyway, it's a very fun molecule. It's now Alex. Excellent. So what is FameLab? FameLab is the largest public-facing science communication competition and training program in the world, taking place across 35 countries. The journey for these Australian finalists started at the beginning of this year when they entered with a 3-minute video. Semi-finalists were selected to present at 4 regional semi-finals. The semi-finalists then underwent training from professional science communicators as well as one-on-one work with experts in their field. And then 12 finalists were picked to come to Perth for a 3-day masterclass in science communication. The finalists stayed at Forest Hall, where I live as a Forest Research Fellow, and I had the opportunity to meet the amazing finalists on Tuesday night, along with a lot of the other scholars and fellows in the hall. And I had the privilege of running a workshop with them yesterday. And hearing about the adversities that they had overcome in order to be here today is a true inspiration. Because you might not realise that it's really challenging to communicate science as a scientist. We're tasked with the formidable goal of trying to generate knowledge as well as communicate that knowledge, firstly, to our peers, to academic peers who are brutal. And we have to convince them, and they're so sceptical, that our new knowledge is worthy. But on top of that, we really want the public to understand the impact of the research that we do. And the public doesn't have years of training that we've had in our discipline, so we must translate our work into understandable story that can connect with people. This dichotomy has led some to suggest that we need professional communicators of science instead of scientists who are great communicators, that, scientists are just not cut out for communicating science and it should be left up to the professionals. But I hope tonight you will realise that the finalists demonstrate this is completely false, that scientists can communicate their science brilliantly and with authority. This authority is critical for us to combat the disinformation that abounds around scientific problems we face. As a researcher in climate change and green energy, this problem is particularly acute for my work as well. And this is what makes me most excited about FameLab. It's not just the truly extraordinary finalists that you see here today, but the thousands of scientists all around the world who have been trained through FameLab in the art and craft of the public communication of science. Alongside these introductions, it's important to acknowledge that FameLab is only made possible from the generous support from the Cheltenham Festivals, the McCusker Foundation, Curtin University, Murdoch University, the Western Australian Museum, the Western Australian Government through the Department of Jobs, Tourism, Science and Innovation, the Community Broadcasting Corporation, the Forest Research Foundation, and the Comet Science Communication Training. And of course, our esteemed judges who will be selecting our Australian FameLab winner who will participate in the international competition. Paola Magni, Senior Lecturer in Forensic Science and Associate Dean of Engagement, Murdoch University. Katerina Doty, School of Biological Sciences, UWA Oceans Institute, and Lecturer, School of Molecular Science. And Jennifer McElwain, Head of Science, WA Museum. Now, please welcome to the stage Alec Coles, OBE, CEO of the WA Museum. Alec.
Thank you, Jacob. I brought a prop as well. That's gravity for you. I would like also to acknowledge the traditional owners of the land on which we meet, the Whadjuk Noongar people, and pay my respects to elders past and present. And Jacob, I'm so pleased you did all those acknowledgements, particularly Minister Dawson's portfolio, which is so extensive. It's no wonder he can't join us till a bit later this evening, but I still acknowledge him anyway. And I had the great pleasure of hearing him speak at a conference yesterday, and he really is so passionate about science. And so well informed, fantastic. Also, obviously, Carroll Bishop, CEO of the Foundation for the WA Museum. Wonderful to see Malcolm and Tonya McCusker here from the McCusker Charitable Foundation that has been on this journey for the whole time with us, so thank you very much indeed. Again, you mentioned James Avanitakis from the Forest Research Foundation. James and I think, go to every function together, and people are starting to talk. So, James, it's nice to see you again. And former Chief Scientist Lynn Beasley, more of her later. It's customary to quote Albert Einstein on these occasions, so I will. All of science is nothing more than the refinement of everyday thinking, wrote Einstein in 1936 in a paper entitled Science and Reality. Well, that may be Physics and Reality, beg your pardon. Well, that may be the case, but I think most of us tonight would acknowledge that our finalists have taken refinement to another level and progressed well beyond everyday thinking. Having said that, the point Einstein was trying to make was that science, and physics in particular, were both based in and applicable to all aspects of our lives and the phenomena associated with them. Because, of course, science, technology, engineering, and maths are everywhere. The food we eat, the clothes we wear, the vehicles we travel in, the electronic gadgets that seem to rule our lives, the medical procedures we experience, and not to mention the damage that we inflict upon our planet, literally everywhere. Rosalind Franklin, one of the unsung heroes of the discovery of the DNA double helix, two blokes, of course, took the credit, put it succinctly when she said, "Science and everyday life cannot and should not be separated." WA Museum has a distinguished reputation in both scientific research and scientific communication. Our biologists are at the forefront of studying and describing the biodiversity of our vast state and the seas around it. They published 45 peer-reviewed papers last year and described 33 new animal species. And how can we conserve our biodiversity if we don't know what is there? And when asked what these people are doing under Jen, who's great to see her on the judges panel tonight, I just say they're saving the world, because I really believe they are. Our education and professional training programs are aligned to STEM education and sustainability. And in the last year, we ran well over 100 workshops, nearly 3,000 students and 500 teachers. That's science communication in action. And that's why we got involved with FameLab. Well, that and because Lynn Beasley told me I had to. And FameLab originated in the UK and was created, as you've heard, by Cheltenham Festivals. But FameLab Australia originated here in Perth, and it was Lynn's persuasion, it was the support from people like the McCusker Charitable Foundation that allowed us to do it. And that's why, you know, it's run across the whole of Australia, but the final is here. And it's owned by the Foundation for the WA Museum, and we're really proud to work with them on that. And by participating in FameLab, early career researchers don't only get a chance to show us what they're up to, but to show us what great communicators they are. So I'm really proud to have it here, a national centre, a national final. Welcome to all of you who have travelled from the East Coast. I can't imagine why you would want to go back, having come over here. This is such an amazing place for scientific research. This week, Perth is hosting the Plant and Animal Genome Conference, Australia. Some 350 delegates from over 25 countries. Central to this is the amazing DNA Zoo, which just yesterday, this is based in UWA, announced the publication of the genome of the spectacled hare wallaby, Logocestes conspiculatus, the first of 100 genomes of rare and threatened Western Australian species that will be analysed and published. We're a kind of world centre for astronomy. I think the last count was something like 450 astronomers and astrophysicists based here in WA. It's a great place, and these are great people, and you are great people. Let me leave you, therefore, before you take the stage this evening, and I do obviously wish all the participants the very best of luck. But I say, before you take the stage, one last quote from the late Professor Stephen Hawking. Science is not only a discipline of reason, but also one of romance and passion. I'm looking forward to hearing that passion tonight. Thank you very much.
Woo, this is all for the finalists. They're looking so excited to go. All right, so thank you so much, Alec, for that, and some great quotes there. Rosalind Franklin, one of my personal heroes, thanks for that. And now, the presentations we've all been waiting for. The way this will work is I will introduce them from the side there, and then they will do their presentation, and then the judges will provide some questions, and then we'll move through. So, I would like to introduce the first speaker, Cintya Dharmayanti, with her presentation, Behind Enemy Lines, Tiny Assassins in the War Against Cancer.
In the war against cancer, your body is a battleground. The enemy is ruthless, constantly multiplying, invading, and destroying. For decades, our front line of attack has been chemotherapy. Potent drugs that act like powerful biological bombs to destroy cancer cells and prevent their spread. Unfortunately, many chemotherapy drugs are non-specific and can invade all parts of the body, meaning they not only kill cancer cells, but healthy cells too. And sadly, for many patients, that collateral damage leads to devastating side effects. It's like using a nuclear bomb to demolish a house. But amidst the rubble emerges a tiny hero, a nanoparticle, a teeny tiny drug carrier too small to see with the naked eye. About 1,000 times smaller than the width of a single human hair, these nanoparticles have the ability to encapsulate chemotherapy drugs and deliver them to the tumour site more directly. Kind of like how these balls are trapped inside this balloon. But what is it about their size that helps them do this? Well, unlike healthy blood vessels, the vessels surrounding tumours are leaky, which nanoparticles can use to their advantage. Because they're so small, the nanoparticles can squeeze through those leaky blood vessels to deliver drugs to the tumour site, and in doing so, minimise harm against healthy cells. But while this might sound well and good, we still have a problem. There's nothing to tell the nanoparticles when or where to actually release the drugs, and as a result, they can sometimes get stuck inside the nanoparticle or get degraded before they're even of any use. So, the nanoparticles need to be smarter. They need to be stealthier. They need to be assassins, transporting drugs behind enemy lines and killing them from the inside out. And that's what I do in my research. You see, by attaching special chemical groups to these nanoparticles, we've given them the ability to sense that change in environment and release the drugs in response. Because inside each cell are compartments called endosomes, small pockets with a more acidic environment than that found outside the cell. So by carefully designing the chemical structure of our nanoparticles, we've given them the ability to sense that change in environment and release the drugs in response. We did this by touching special chemical groups, which outside the cell have no charge. But once they're exposed to an acidic environment, like that found in the endosome, they take on a positive charge. When that happens, those positive charges repel one another, forcing the nanoparticle to break apart and release the drug inside. So while our battle against cancer still wages on, just remember that we're not planning on waving a white flag anytime soon. With more research and time, we can harness the power of these tiny heroes and turn the tides of this war for good.
Thank you, Cintya. I'm very lucky because I got a nanoparticle.
I'm so sorry about that.
Oh, it's good. I mean, it's the future, so I have the future in my hands. So I was wondering, there are many different types of cancer, unfortunately. So is your research targeting specific type, or tell me?
Yeah, so my work in particular doesn't focus on any particular kind of cancer, but one thing that we can do, which is really cool about nanoparticles, is we can attach specific targeting groups to the surface of the nanoparticles, which can make them more targeted towards specific cancers, like, let's say, ovarian cancer or prostate cancer. So there definitely is a possibility, but not something that we're doing in our work.
Thank you.
Thanks, Cintya. So can you describe to the audience what the one take-home message that you'd like them to remember from your presentation tonight?
Yeah, I think the take-home message would be that we have this really cool new technology where we can essentially load pre-existing medications that we have, like chemotherapy, into these little drug carriers, and we can make those existing therapies more targeted to things like cancers using that technology.
Our next finalist is Ashleigh Geiger with her presentation, A Tiny Tool for Saving Sight. Woo!
Did you know that despite their small size, after the brain, the eyes are the most complex thing in your body? I am fascinated with them, but hey, I'm a molecular biologist. Liking small stuff is part of the job. Even smaller than the eye, of course, are the cells that make it up, and my favourite are the rod cells. You know, you have nearly 100 million crammed into each of your retinas, and they look after two things: your low light vision and your peripheral vision. They're why you can drive safely at night. They're why you can look dead at me and still kind of see my giant eye over there. But for 2 million people worldwide, their rods are dying, and it's sending them progressively and irreversibly blind. They have retinitis pigmentosa, DNA. You may know of DNA as the instruction manual that's carried by our cells. Well, patients with the most common form of this disease, they have a tiny mistake in their instructions, leading to a buildup of toxic protein in the rods that kills them. Right now, this is an incurable problem. But luckily, I don't just like small things. I also happen to love problems, and I think I have a solution to this one in here. Ironically, you cannot see it, but in this tube is an incredibly powerful tiny tool. It's called CRISPR, and it's a DNA editor. CRISPR cuts DNA in a way that is programmable. We equip it with a custom guide molecule that takes it to the exact place in the DNA we want to cut, and after that happens, some DNA is deleted, a bit like erasing some of the words in the instructions. So I asked myself, could I get CRISPR to erase some of the words in the instructions to the toxic protein so it doesn't get made and the cells don't die and patients don't go blind? It's such a beautifully simple idea that I thought to myself, somebody must be doing this. So I checked, and they are, but there is a problem. They're designing their guide molecules to work in the eyes of mice. And mouse DNA, it's just different to human DNA. A new approach is needed. That's where I come in. In my PhD, I've been developing the next generation of human-specific CRISPR therapeutics for retinitis pigmentosa. My research shows that when I use CRISPR to target the DNA of millions of cells in a dish, it is so good at erasing that mistake, I basically can't find it. So now I'm testing it in a unique model. It's a mouse, but it has the human DNA target. So the way we use CRISPR in my mouse is identical to how we'd use it in a patient. It could revolutionize treatment of this disease. You don't need to be a molecular biologist to tell that small things can have a big impact. This tiny tool will save sight. Just you wait and see.
Thank you, Ashleigh, so much for that, and I'm so glad you didn't pop the eye.
So am I. Frankly, I've been worried about it for the last 2 hours solid.
Judges, over to you for questions.
Thank you, Ashleigh.
Thank you.
So do you think within your time working on this will become publicly available?
Thank you for that question. Yes, I do. I think we are beginning to see therapeutics like this actually enter the market right now. There's a particular DNA editing CRISPR therapeutic that's actually used for a different form of eye disease that is now in clinical trials. There's a gene therapy, which is more like replacing the DNA than cutting it up, that is in the clinic now for eye disease. So we are seeing a rapid technology development and a rapid technology uptake for these particular diseases. And there is an urgency. There are no cures for this at the moment, and so we really do have to drive as much as we can towards trying to save sight for these patients.
This is sort of a follow-on question from Kat. So it's all about the rats and the mice. So when will this research start to sort of work with humans?
Yes, so at the moment the work that I'm doing is in the preclinical stage. So that means that we're testing it in a mouse model. At that point, if we get really convincing data, we could look at potentially seeing if a clinical trial company in the US, which is where the predominant patient base is, would be interested in trialling this technology in a patient base. Clinical trials do take a fair bit of time. There's a recruitment phase that can take several years sometimes. But we also do know that there are probably around, at least for this particular DNA mutation that I am studying, a particular area in the DNA, there are at least 600,000 people in the US who would have this particular disease. So we'd hope that uptake of the trial would mean that we could progress this relatively rapidly. Thank you.
Great, we'll have to keep an eye out for that. There we go. Our next finalist is Olivia Carroll with her presentation, Tuning In to Our Hormones to Better Understand Asthma.
How good's puberty? Hair starts growing, pimples start showing, those pesky hormones are well and truly flowing. We all received advice on how to best navigate this new and exciting chapter of our lives. But I highly doubt that any of us, when we were going through puberty, were told, hey, you're going to need one of these now, an asthma puffer. It seems strange. We don't often associate asthma, a disease of the airways, with puberty, a time when hormones are skyrocketing. I want to change that. I want all of us to start thinking about hormones when we think about asthma. Because did you know that after puberty, females are more likely to have asthma than males? Why is that? Can female sex hormones influence the development and severity of asthma? And if so, how? Well, let's think about hormones for a moment. Hormones are our body's radio waves. They broadcast messages all throughout the body. Just like a radio receives signal through its antenna and plays a certain tune, our cells throughout the body, here's one I prepared earlier, can receive hormone messages through specific receptors which can influence how that cell functions. I've looked at 2 hormones as part of my PhD, estrogen and progesterone. You may be familiar with these hormones and the messages that they send to our reproductive system, but I'm interested in the messages they send to our lungs. Can our hormones communicate with the cells involved in driving asthma? Turns out they can. Using experimental models of asthma, I have found that our hormones can influence the way in which cells in our lungs generate the energy that they need to function, the energy that they need to drive inflammation during an asthma attack. Otherwise known as cellular metabolism, I have found that estrogen increases key components of cell metabolism, and consequently, estrogen is associated with more severe inflammation during asthma. Progesterone, it appears to be doing the opposite. Naturally, this raises the question, well, what happens if we turn the volume down on these hormone signals during asthma? Say, for instance, by taking an oral contraceptive pill. Well, we have found both experimentally and clinically that for some women with asthma, taking an oral contraceptive pill can reduce key features of their disease. So we could think of the pill as the video, because as they say, video did kill the radio star. My PhD is looking at hormones in asthma, and I'm really excited about the potential that this work will have in other inflammatory disorders. Ultimately, I hope that this encourages all of us to tune in to our hormones when thinking about asthma and disease.
Thank you, Olivia, for that great presentation. Judges, over to you for questions.
Olivia, I'm not happy. Because I have a daughter that is going to puberty, and I know that there was going to be a mess, but now I know even more. So, now that you ruined my night, is there any pre-sign that asthma can be one of the issues during the puberty?
Not quite yet. So, when we look at kids with asthma, boys actually have asthma more so than young females. However, at puberty, that completely switches, and females take over and they have asthma more so. There's been some research suggesting that the earlier onset of menstruation may indicate onset of asthma, but it's still quite complex, and there's unfortunately no signs that may indicate the onset of asthma during puberty.
Interesting. Thank you very much.
Oh, hello, Olivia. My question is, what was the most surprising thing you discovered while you were studying this in your PhD?
Oh, that is such a great question. So many things, but I'll keep it short and sweet. I think our work with the oral contraceptive pill has been really interesting. Moving forward with this, we don't want to go and prescribe the pill to women with asthma because we know that's not possible, and we also know that's not possible for males at this point in time. But we want to figure out what the pill's doing at a cellular level to enable it to be protective for some women with asthma, and can we harness that and move forward and develop a treatment based on what it's doing. So I think what we've found with the oral contraceptive pill has been most interesting from this work.
What amazing papercraft, right? Incredible. So our next finalist is Olly Dove with her presentation, Unveiling the Underwater Adventures of Seabirds. Woo!
It's okay. I don't think there's any need to be nervous. They look like a lovely group of people to me. Oh, just take a deep breath. Do you feel better? Great. And actually, speaking of deep breaths, do any of you think you could hold your breath for a minute? What if you had to hold it for a minute and free dive down to 70 meters? No takers? Well, this guy can do it, and he can catch his dinner at the same time. I'm Olly Dove, and appropriately for my name, I study the diving behaviour of seabirds, and in particular, I study the shearwater. So in Lutruida, Tasmania, shearwaters raise their chicks on land, but to get their dinner, they have to go to sea, and they can go all the way to Antarctica, and they can go all, thanks for that, the way back within just 2 weeks. And I find it incredible that a small 600-gram or so bird can do that commute when I start puffing after running across a stage. Now, fortunately, they don't have to go that far, and it's their feeding around Tasmania that's so crucial for raising their chicks successfully. And since they're near Tasmania, they're near humans, which means they're going to be near boats, marine farming, and the waters in southeast Tasmania are actually warming at 3 to 4 times the global average. So we want to know if these external factors are impacting their behaviour. But to do so, we need to understand their behaviour, which is happening out at sea, not again, thank you. So how are we going to do it out there? I, for one, am not nearly a good enough swimmer to follow them out. Well, fortunately, we have technology. And shearwaters are burrowing birds, which means they live underground. So once we find our shearwater, we can... Do you want to show them what's on your back? We can attach a small device called a biologger. It doesn't look like much, it just looks like an eraser. But they take it to sea, they do their diving, they bring it back, and it's recorded 3 important things. The GPS, so location, the accelerometry, which means the speed, and the pressure, which we convert to depth underwater. And with speed and depth, we can identify different movements and classify different dive types. So we know where they're doing smooth dives to look for food, and where they're doing dives with oscillations, which is just a fancy word for wiggles, and those dives might be where they're collecting food. So knowing where the different movements and where the different dives are happening means that we can identify where the important regions to protect are. So, if I may be allowed to paraphrase an old favourite TV show, save the shearwater, save the world. I told you they'd like you.
Thank you, Olly. And do we have a name for your little furry friend?
Jodie, the short-tailed shearwater.
Jodie. Well, thank you, Jodie, as well. And judges, do you have any questions for Olly and Jodie?
Yeah, fantastic. Thanks, Olly. Sounds like you work in some amazing places. Can you describe to the audience a little bit some of those sort of field places where you work? I mean, it sounds amazing.
Definitely can. This is actually our favourite question to answer. So I work on Wedge Island in Tasmania. It's just off the peninsula. And this island is full of seabirds. There's an overlapping colony of shearwaters and little penguins. And we camp just underneath the colony for up to 5 weeks at a time. And it's not classy work because there's no showers and there's no toilets. Wow. So it is bare minimum and it is amazing.
Doesn't sound like I'll be volunteering anytime soon.
Oh, no!
So I'm in forensics, and you tell me that you are a bird stalker.
Sorry, I didn't catch that.
You're a bird stalker.
Yeah.
So I was wondering, is there any pattern of movement of this bird that is connected to the type of food that they look for?
Yeah, and that is a wonderful question. Do you want to take it or should I? Okay, he's feeling shy again. So the movement can tell us about the prey species because some of the prey of seabirds have this sort of migration throughout the day. So at different times, they're going to be in different places. So if they're doing a lot of feeding and they're moving very fast, very sharp angles, it's going to tell us about the fish or the krill that they're going to be targeting, as opposed to if they're going down deeper and they're moving potentially slower, it's going to be a different prey species.
So it's a passive way to know also about their diet.
Yeah.
It's interesting.
Yeah.
And a passive way to know what is in the water instead of environmental DNA. Good.
Yeah. Yeah, so his behaviour can tell us about other species as well.
It's a spin-off research.
Yeah. Awesome. Bye-bye.
Our next finalist is Tian with her presentation from Anti-Hero to Antidote.
It's Tian. Anyway, I sometimes think that Professor Charles Xavier of X-Men fame and I are kindred spirits. You see, down in the depths of the incubators in my lab, surrounded in a warm, nutrient broth, I have thousands upon thousands of mutants. Now, these mutants are actually clones of each other, that is, identical in every way, except for one defining trait. Now, once in a new moon, I'll gather together my mutant army, and I'll put them through a training gauntlet, a battle royale of sorts. I'll flood their homes with venom and see who survives. Okay, so maybe I'm a bit of an anti-hero. But seriously, out there in the real world, our battle with venomous creatures is ancient. Snakes, spiders, jellyfish, they're so prevalent in our conscious and pop culture because they are an ancient foe. Although beautiful, they've developed painful and deadly weapons. Oh, safety first. A vial this small of some species can contain enough venom to kill up to 10 adults. And this battle is ongoing. Over 138,000 people still die from snakebite alone worldwide. Many more, millions, survive, but may have lasting disability or disfigurement. Our current treatments for stings and bites, although life-saving, are also a bit old-fashioned. And we're lucky, here in Australia, to have a great healthcare system despite our plethora of creepy crawlies. However, elsewhere, these medical facilities may just be too far away or lacking the basics of just refrigeration, and therefore are limited in the help they can provide. So back to my mutant army of cells. You see, I have mutants that cover every single human gene of the human genome. That's around 18,000 different mutants. So very quickly, from seeing which ones survive my venom onslaught, I can pinpoint those that have that X factor, or superpower, if you will. And with this technology, I have in fact identified the exact human genes that venoms from bluebottle jellyfish, and importantly, African spitting cobras, use to kill our cells. With this information, I've repurposed cheap, readily available drugs that can be used on-site, and as a world first, prevent the debilitating effects of these snakes. So, to paraphrase a superhero icon, with great venoms comes great responsibility.
What a great presentation. Judges, over to you for questions.
Hello, Tian. So my question is, if I'm out in the bush, do I need to carry 10 EpiPens with me? Or can you put them all in one and I can do it?
Yeah, so our hope in the future is using this technology to basically look at all of these different venoms and hopefully, and we are, finding genes that are basically universal across these different animals. And hopefully we can provide and create a broad-acting antidote, yeah.
Tian, fantastic. Having been the victim of a stonefish sting, I know the pain that it can inflict. It's really quite extraordinary.
Yeah.
And also having done work throughout the Pacific, I know that you know, particularly stonefish are a really big problem. How many years do you think it will take for you to sort of reach, I guess, a point where you can start to roll this out so that it's more readily available?
Yeah, so at the moment with our spitting cobra venoms, we are hopefully, this is something that we are publishing now and hopefully can be brought to the public very soon. But looking at across the broad spectrum of all the venoms, there's so much out there, it might take a little bit longer for those.
Sure, thank you.
so our next finalist is Jodie Pestana with The Surprises of Motherhood.
Come on, James, hurry up. You're going to be late for school, buddy. Sit down. Let me do your shoes. Honey, what are those? You can't wear your Spider-Man slippers to school. Katie, come on, get your lunch. Here you go, honey. Huh? What do you mean you don't like cheese today? Motherhood is full of surprises. But what if I told you the biggest surprise of motherhood is actually not about the kids? It's about what happens to the mum. And more specifically, what happens to her brain. Now, during pregnancy, the mother's hormones, estrogen and progesterone, are produced by the ovaries and placenta in extreme amounts, higher than any other stage in the female lifespan. These hormones reshape the mother's body to help grow and protect the fetus, leading to physical changes like a growing belly. What we don't see, however, is that these hormones are also travelling up the body and reshaping the brain. For example, pregnancy and the postpartum period produce structural changes in brain regions related to mothering, but also in brain regions related to learning, memory, and anxiety. But my mum says she felt permanently changed after having me. So what happens to the mother's brain after the postpartum period, when the kids can tie their own shoes and make their own lunch and are all grown up? This is where my research comes in. In my research, I use animal models to investigate whether becoming a mum has long-term effects on the brain, and in particular on brain regions that control our anxiety. Using biochemical techniques, I found that motherhood increases chemical signals in brain regions such as the amygdala, the anxiety hub, and that these changes persist long after the offspring have left the nest. But what might these changes in the brain mean for the mum? Well, I've shown that these permanent shifts in brain chemistry change how mothers express their anxiety, but also how they respond to commonly used anxiety treatments. For example, using animal models, I've shown that common anxiety medications like Valium and Prozac produce different behavioural and physiological effects in non-mothers compared to mothers. Now, my findings have significant clinical implications, particularly for the 1 in 4 women that will experience an anxiety disorder in their lifetime. In particular, my research could lead to anxiety treatments that are specifically tailored towards the mother's brain, so that mums receive the best care possible. Motherhood is an exciting, lifelong journey full of surprises. Not just for women, but also their brain.
Thank you, Jodie, and your surprising brain that came out of nowhere. That was amazing. Judges, over to you for questions.
Thank you, Jodie. My question is, what have you found is the biggest misconception people have about your research and all of this, mental health with motherhood?
I guess biggest misconception is that people are unaware that motherhood changes the brain. I guess it's quite common that this peripartum period is associated with mental illness, anxiety and depression for a large proportion of people, so between 10 and 20%. And often maybe people aren't aware that there's a biological reason for this. So that's something that I would like to put out there, that it's not your fault. There's a biological reason for why you're feeling that way, and there's researchers that are trying to work it out and trying to make the treatments better for you.
Awesome.
So baby brain is a thing.
Yes.
So now that you are into science communication, are you planning to consider communicating this to the partners of the moms?
Yes, that's a great idea. Strongly
support groups.
Pardon?
Serious. Support groups would be great.
Yeah, definitely. And I'm super on board for science communication and
communicating to everyone. It's a support network that we need to really be communicating to, because yeah, it's not just biological, there are socio-cultural stress factors that could also be contributing to mental health conditions during this time as well, and it's important that, the whole network is in that person's life is on board and understands that, that there are biological reasons also, and these people, need help, and hopefully, that they get it, and it's good for them.
Thank you.
All right, so our next finalist is Caerwen Beaton with the very tasty title, Can Cake Counter Concussion?
Today, I'm going to ask you to join me in a science experiment. In a second, I'm going to get you all to close your eyes. Now, I promise there are no jump scares. We're all just going to use our imagination. So, if you all close your eyes, I want you to imagine a piece of cake. You might be thinking of a rich chocolate cake, maybe a squishy sponge cake. Maybe you're thinking of a very particular cake, one you had one time where the icing was smooth and silky, or it was just soft enough without falling apart. I don't know about the rest of you, but I'm starting to get hungry, so I think we can all open our eyes. Thank you. Ivan Pavlov would say that now when I ring this bell, you'll think of cake. I want you to hold on to this idea, because I'm going to bring it back a little bit later. But for now, I'd like to talk to you about concussion, something I'm sure you've all probably heard before. But what you might not know is the impact concussion can have on your brain activity. We rely on our brains to send electrical messages through multiple pathways and exactly control our movements. There is very little time between us thinking, open our hands, and they open. But when we get an injury to our heads, like a concussion, these messages can stop sending in the way they used to. But what's the big deal? When we get a concussion, we just rest and we're fine, right? Well, that's not always the case. Up to 50% of people don't recover. They can go on to experience things like headaches, nausea, memory problems, sleeping too much or too little, and even suffer from anxiety and depression. This can go on and on for months and even years after the injury itself. Did any of you think of cake? Yeah. Maybe not, but what I'm trying to demonstrate is that we can train our brains to do things like think of cake when a bell's rung. What if I told you we could use a similar technique to change how the brain sends messages? We do this by measuring the electrical activity in someone's brain and then rewarding them every time their brain goes within a normal frequency. So essentially, we can reward them with cake, and then we repeat the process every single time. So they get the cake every single time they get the answer right. This becomes like a game for the brain, and it takes a little bit of time to get there, but in the end, we can move them towards the desired range. Now, with my research, I'm trying to help those who are still suffering and haven't recovered by fixing these messages. If we achieve this, it'll be the first ever concussion treatment that targets not the symptoms, but the brain itself.
Thank you so much, Caerwen. Judges, over to you for questions.
Can you train me for no cake? No, but serious, like the message that you can train on is only positive message or can be a negative message?
So it is based off positive reinforcement. So they don't actually get cake. It would look more like getting around 100 slices in 21 minutes. So I don't think anyone can eat that much cake. They get a positive reinforcement of a stimulus, so they get a dot and a beep, and our brain likes to see it. So we get this dopamine hit, and then it's like a game, so we want to see the dot and the beep again. So like, okay, how did we do that? We did that by putting it within this nice frequency. We're making the messages right again.
Yeah, I was hoping good way to have a diet, but no.
Caerwen, so concussion is obviously a huge issue across all of the different football codes. So are you allowed to, or can you share some of these sort of preliminary results? Is it positive? Are you starting to see some, with the work that you've been doing with some of these, your participants?
Yeah, absolutely. I mean, this does stay between you, me, and the entire crowd. It is still up and coming. This is my PhD, so we're looking for more recruits. But at the moment, we've done a couple cases who've done this treatment. Now, we're looking at it in a more long-term time frame. So I wouldn't say so much sporting at the moment where it's quite wanting to get them back on the field. We're looking at people who aren't recovering, so that quite long-term goal. But of the 3 people, we saw a full resolution of symptoms. So one in particular was suffering of headaches quite frequently, like weekly and almost daily. And after 6 weeks of training, they were completely gone.
Wonderful. We'll be looking out for that paper. Our next finalist is Ryan Hickmott with his presentation, Build a Brain Workshop, Solving the Mysteries of Neuroscience.
The human brain. It's a funny little thing. A squidgy, wrinkly mass of electrified meat hidden away in your skull and responsible for everything that you think, feel, hear, say, see, and do. We've all seen one. Some of us, I dare say, have even got one. But have you ever wondered why it looks the way it does? Well, these wrinkly trick of evolution to fit more neurons into the same space. And more neurons means more processing power. So really, without our folds, we couldn't do all the things that make us human, from laughing at a good joke to feeling sad about having to go to work on a Monday. For better or for worse, more folds just equals more smarts. But between you and me, there's something kind of embarrassing. See, we still don't really understand how our cells coordinate our brain's growth. And this is a problem with brains as big and complex as ours. Changes to our folds can have major consequences, including epilepsy, schizophrenia, and even dementia. So, we need to learn about brain folding. So how do we do this? Well, for years, scientists have learned quite a lot from a little help from the ferret. See, ferrets are unusual. They're a small mammal that has a folded brain, which is really good for us, but they also grow these folds about 3 times faster than a human brain does. So ferrets are fantastic for studying this process. But here's the thing. This little guy is super cute. Not to mention, it's the 21st century. Can't we do better than testing on animals? Well, brace that folded brain of yours, because here's where things get really exciting. My research skips the need for a ferret by growing mini brains in a dish, aka brain organoids. Now, to make mini brains, you first need some human stem cells. These are unspecialized cells, like blank canvases, and they can become anything. All you have to do is push them into becoming neurons, and they'll start to self-assemble into a mini brain that we can watch grow in real time. Isn't that amazing? But there is a catch. Despite being so amazing, human organoids just don't fold like a real brain does. So I've been trying something new in our quest to make a folded mini brain by making them from, you guessed it, ferret stem cells. And just imagine what this could mean for research. A tiny brain that we could use to unlock the secrets of how the brain folds, while testing new medications to treat various brain diseases. All this without costing any animal lives. And hey, this is just one project. We've already made incredible discoveries using human organoids that make me very optimistic about the future of medicine and neuroscience. So I invite all of you here today to keep the optimism alive when you go home by keeping an ear out for organoids in the media, as these incredible tools bring us closer than ever to a future where neurological diseases are a thing of the past. Thank you.
Thank you, Ryan, so much. I will never forget that a ferret has a folded brain. And
Excellent.
judges, over to you for questions.
Thank you, Ryan.
Thank you.
Yeah, I guess my question is, do you face any controversy growing brains, live brains?
Yeah, it's
in
an
a lab?
interesting one. It's definitely not without any ethical concerns. In my head, it's always an alternative to using a whole animal. So obviously things like rats and mice are very common in lab research in general. They actually have smooth brains, incidentally, which is why the ferret for so long has been such a good animal for us to use. But yeah, in the last 10 years, we've invented these things called organoids, and just the potential to discover things so quickly and have so much control of that experimental setup with no animal costs makes it a hugely more advantageous kind of ethical situation. But like I said, they're not completely without their ethical concerns. They're definitely not conscious at anything like at this stage. But we like to think ahead and think of what will happen one day when our technology does get bigger and better. Will there be consciousness-like behaviors? Would there be the ability for it to suffer? This is a long way off, so we don't have to worry about this right now, but it's always good to be talking about these things. But the other good thing about this, and I won't go on too long about this question, is historically when using stem cells, we use embryonic stem cells, which definitely have their associated ethical concerns. We have this new technology that's come out in the last 15 years where you can take any cell in your body, so skin cells, because they're quite accessible, give it about 4 genetic factors, and it will turn back into a stem cell. And these are called induced pluripotent stem cells. So you can actually take one from you or anyone in this room and say you had a genetic condition. We could model your specific disease using a brain organoid or any organ. So yeah, they're incredible things, and there's lots of good ethical workarounds that have been coming to light in the last 10 years.
So Ryan, you looked pretty comfortable up there on the stage. So my question is really around what's the sort of the biggest benefit that you've got from participating in this whole FameLab experience?
I think a lot of it has been just kind of reinfusing me for the idea that it's worthwhile talking about science. Obviously, I always knew it was, but I mean for me personally, because sometimes you get so tied up in being in the lab, long hours, and particularly being at the end of the PhD like I am and all the other finalists are, you can sometimes get very narrowed in, and it's good to step back and just meet wonderful people who encourage you and give you new skills. And I think beyond anything, the other finalists have been incredible, and so has our management team. So as sappy as it sounds, like just the people I've met on the way have made it pretty fantastic.
That's it.
Cool. Thank you so much.
Thank you. All the best for writing up. All right, our next finalist is Matthew Shaw with his presentation, Lunacy.
On the moon. Imagine the view. It'd be the greatest view on Earth. Sort of. I mean, it wouldn't be on Earth, but you get the point. There's one issue, though, one problem with that plan. Apparently, it costs a lot of money to take things to the moon. In fact, right now, it's about $1.2 million per kilogram. That's worse than Sydney prices. I might need to downsize to a small hut. Or maybe I have another option. What if, instead of packing everything on a rocket and launching it all to space, what if we could just build it there, on the moon, from local resources? Interesting idea, right? But if we wanted to build something like a house on the moon, what do we use? What's there? Let's have a look. This is the moon. You may have seen it before. If we look carefully at the moon, we can actually see lighter areas and darker areas. These light areas we call the highlands, and the highlands have more aluminium in them. That's why they're lighter. The dark areas we call the mare, and the mare has more iron in it. Okay, so aluminium and iron. What could we make out of aluminium and iron? I mean, structurally, pretty much anything. We could build a radio telescope on the moon to see further into the universe than we've ever seen before. Or maybe a fleet of solar power satellites to provide green energy to the world. We could even build habitats. We could build that house. Yes! Now, it does get a little bit more complicated. The metals on the moon are kind of locked up in the rocks. And so if we want to use them, which we do, first what we need to do is extract the metal from those rocks. That's what I do. I'm an extractive metallurgist, which means it's my job to extract metals, it's very much in the name, from rocks. And I do that with space rocks, so I'm what's called an astrometallurgist. And I look at different physical and chemical processes that allow us to extract resources from rocks in space so we can build things there. Isn't that cool? I mean, I think so, but I'm a little biased. I'm going to finish this up, but I want to leave you all with a little bit of homework. Next time you're outside at night, I want you to look for the moon. And I want you to really think about what you're seeing. Look for these lighter areas and the darker areas. And remember that what you are seeing is metals like aluminium and iron. These metals that one day we will be able to use to build things in space. So, yes, maybe one day I can build that house. The house with the greatest view on Earth. Sort of.
Thank you, Matthew. And we all going to do the homework, right? Yep. All right, judges, over to you.
Thanks, Matthew. So I guess my question is, and this is just because I've seen a lot of movies where mining the moon is like the villain plot. What is the biggest kind of misconception about mining space that you think, what are the biggest benefits that we don't get to hear about?
Yeah, so one of the biggest benefits, and the reason that certainly people like NASA have been looking at it for so long, is that getting things to space is really expensive. In fact, 90% of that rocket that you see, the massive thing, is really just to get things off the surface of the Earth. And so it takes the same amount of energy for us to get from the surface of the Earth to low Earth orbit, that's a couple of hundred kilometers up, as it does to get from the moon to low Earth orbit. That's like 380,000 kilometers. Right? So if we could source things like fuel or any other resources in space, we can do anything in the solar system. And probably the biggest misconception is that that thing is really big. I know that it looks kind of small when we look up at the sky, but it's a sixth the size of Earth. It's massive. So we're barely going to scratch the surface.
So let's talk real estate. If Christmas is coming, so maybe it's good time to buy something, maybe a lot on the moon. Where is the best place to build a house there?
Oh, the best place. This is difficult, isn't it? I think at the moment we'll ignore the legal aspects of trying to buy bits of the moon. We'll leave that for next time. The best place at the moment that we're looking at is the South Pole. So you'll notice that NASA and even the Indian Space Agency has recently landed their rover just kind of down here. And the reason we're interested in that is that there are permanently shadowed regions on the North and South Pole that have water. Now, obviously, it's not in a liquid form, it's all ice, but water is amazing, right? We can split it into hydrogen and oxygen. Oxygen is good for breathing, which is good. And we can use water for life support, but we can also split it and use that as rocket fuel. So if we were going to build a settlement, it might not be a bungalow, probably more like a bunker. We would probably build it on the South Pole at the moment. That's the thinking.
Sold.
Good.
Great. Our next finalist is Kelsey Poole with her presentation, Could Farming Shed Light on the Future of Male Fertility? Welcome to the stage.
When you think about the future, maybe you worry about things like climate change. Maybe you wonder what our cities will look like or what technology we'll be using. Maybe you imagine a future family. What most of us fail to realistically imagine in this future is that at the rate we're travelling, very few of us are going to be able to naturally reproduce. You're all aware we've just lived through the global COVID-19 pandemic, but what people aren't talking about is we've been living through a silent pandemic of human infertility since the 1950s. And we talk about fertility like it's a female problem. Well, we got that wrong, it's not. In fact, we've seen a steady increase in male infertility. And that's because in our daily lives, we're exposed to these compounds called endocrine disrupting chemicals. And these compounds are changing the way we reproduce. Now, what's really scary about these endocrine disruptors is we're starting to suspect that this infertility could actually be passed on to future generations. So what that means is what you've been exposed to today could actually already be in the process of pre-programming the fertility of your future grandchildren. And trust me, you have been exposed today. These compounds are in our airways, our diets, our personal care products, and they're in the plastics that we're making our children's toys with. Now, if we want to study this event in humans, we're looking at decades of data collection. We're going to be too late. But we're not the only species that are impacted by these endocrine disruptors. They're actually in our farming systems. And livestock are a much better model for fertility because they're not taking decades to have their babies. So to understand how these compounds are shaping the future of male fertility, we look to the sperm of our sheep and cattle. We apply light-emitting probes across billions of cells to physically visualize male fertility. We can measure how safely this genetic material is packaged in that cell, how likely it is to form a successful embryo and pregnancy, or if after exposure to these endocrine disrupting compounds, if these cells simply die. These animals are not just contributing to food security, they're actually shedding light on the future of male fertility.
Thank you, Kelsey, for sharing that important work. Judges.
It's pretty impressive thinking that for our future. So in the farm animals that you looked into, which one is the farm animal that has more effect in the second, third, fourth generation in this sense?
Which animal?
Yeah.
Generally, I look into sheep. So sheep reproduce much quicker than we do. And we're seeing these effects on male reproduction down to the grandchildren, but even their children, so the great-grandchildren, we're starting to see differences in cellular composition.
Thank you.
Kelsey, have you been able to look at organic farming as a means of a control or a comparison against some of the more traditional forms of farming?
I have actually, and we think that these endocrine disruptors are maybe chemicals, maybe you're thinking along the sides of herbicides or pesticides, but they're actually also in the pastures that the animals are eating. So there are compounds called phytoestrogens or plant estrogens, and they're very much in our diet as well.
Our next finalist is Melissa Papini, with her presentation using familiar nursery rhymes to explain the consequences of concussion.
I want to tell you a story about the most famous case of concussion that some of you might be familiar with. Jack and Jill went up the hill to fetch a pail of water. Jack fell down and broke his crown, and Jill came tumbling after. Jack was unconscious, but Jill was not. When asked what happened, Jill forgot. They were examined by the triage nurse, who said Jill was fine and Jack was worse. Scans showed that Jack had a skull fracture, but Jill's scans were normal, nothing to capture. Doctors told Jack he needed to stay, but Jill was sent home the very same day. So it's clear that Jack has had a head injury. Jill hit her head too, she seems fine. That doesn't mean she is. Jill's had a concussion, which can look like an invisible injury. But why is that? So your brain is very soft, and like the yolk in an egg, it's protected by a hard shell, your skull. And when your head is subjected to a sudden force, your brain hits against your skull, causing damage. But if you don't crack the shell, that damage is difficult to see. That's because it's microscopically small, far too small to see on a regular scan. And to make things more difficult is that this damage continues to evolve and worsen over time, meaning symptoms appear weeks and months later, and they aren't unique to concussion, can be easily misdiagnosed. But Jack's injuries were clear as day, so he got rehab and treatment without delay. With all this help, Jack soon got much better. But Jill became different. Everything would upset her. She could no longer sleep at night, always complained that lights were too bright. Headaches and dizziness plagued her days with constant brain fog. Her mind was a haze. But Jill's doctors could never find anything wrong. But a concussion can really last for that long. So the reason Jill's doctors can't find anything is that right now, they just don't have the right tools. But the good news is, we're working on it. I research concussion, and my PhD investigates ways that we can look at this damage to the brain by using clues our body gives us, called biomarkers. I'm interested in 2 different biomarkers. Firstly, a more sensitive type of scan called diffusion MRI lets us pinpoint the brain, looking microscopically, we'll find out where this damage is. But on its own, that's not enough. We need to know what's happening inside the brain causing this damage. So for this, I'm using a blood test, looking for proteins in the blood that are released after the brain is injured. They can tell me what mechanisms are responsible for the damage we see on the scan. Together, this gives us a clearer picture and means that doctors can provide early intervention and treatment so people like Jill don't have to suffer. I'm hoping it goes something like this. Jill's brain was injured, but she needed proof. The biomarkers reveal the truth. When there's no option for testing, how can we be sure? But if we see it and manage it, the next step is a cure.
Congratulations, Melissa, on nailing that poem. And judges, any questions from you?
Thank you. Great rhyming as well. I'm not sure if Jack and Jill was actually about concussions, but that's all I'm going to think about now.
No, it's much worse. Much worse.
So my question is, I didn't even know this, but is it quite common for mild concussions just to go completely unnoticed when they go through a medical thing?
No,
So there has to be a threshold of hurt.
Yeah, so the damage is really microscopic. So a CT scan, for example, would be the most common thing they'd do, and that would be to check for maybe a bleed or a fracture. But the damage that you do in a concussion, you don't usually fracture your skull, and bleeds would be too small to see. So it's really, really microscopic, but it's insidious in the fact that it then just develops and develops over time. So, but still microscopically. So it's very hard to pinpoint with the tools that we've got at the moment.
Melissa, I think there are a lot of parents out not only in the audience, but whose children play sport and suffer from concussion. So can you give us sort of an idea about if people are interested in your research, where they might go to find out more about the work that you've been doing?
Sure. We actually have a charity called Connectivity associated with our lab group. They do incredible work, especially within the community, trying to raise awareness about concussion. They also have a link on their page for any projects that we're doing at the moment. So you spoke to Caerwen earlier. One of the projects is the intervention study, where people who've still got these symptoms 6 months or 2 years later, and there's nothing else really that they can go to or somebody they can see. So enrolling in that, or just contacting us, we can tell you everything you need to know. But we're based at Curtin and the Parent Institute, and we'd be happy to hear from anybody.
Good stuff, thank you.
All right, lucky last. Our final presenter is Hannah Morgan with Data-Driven Detective, a new tool for vaccine safety investigations. Put your hands together.
I'm a detective. But not your average detective. Instead of investigating crime, I investigate vaccine safety. Clinical trials test the vaccine to make sure that they're safe and they work before they're allowed to be given to the community. But after the vaccine is approved, it is my job to keep investigating vaccine safety after it is given to millions and millions of all kinds of people. And the main way we find out about vaccine side effects is when people report them to us. And today, I'm going to take you through 3 of my report investigations. So, investigation number 1. Here we have a young boy who was vaccinated, and 10 days later he falls off his skateboard after a failed triple kickflip and breaks his arm. And this probably isn't related to the vaccine. Investigation number 2. Here we have a young woman who's vaccinated, and within the hour she's got a sore red arm at the injection site. And this probably is related to the vaccine. All right, these ones are easy so far. But some are trickier. Take this man, for example. He gets a vaccine and 5 days later starts to feel unwell. He's rushed to the hospital, they run some tests, and it's determined that he's got a blood clot. So what about this one? Is the blood clot related to the vaccine, or did it occur entirely by chance? Well, you see, we found that for rare situations, like blood clots, we can't solely rely on reports to our portal. And that's because not everybody does report, whether that be they don't know how to report, they don't know that they should report, or they just can't be bothered. Now, for common things like a sore arm, that doesn't matter so much. We've got plenty of data. But for rare events that are medically unclear, we need all the data we can possibly get. So, I am designing a new investigation tool so that I can get rid of this. My new investigation tool links vaccination records for every single person vaccinated in Victoria, and it links them with their healthcare experiences, including their trips to the hospital, their trips to the GP, and even their births. So now, without the need for reports, I can see people's side effects after the vaccines. It is important to say, though, I have no idea who any of these people are because their privacy is essential for me. But now, instead of looking at one-off experiences like one man with one blood clot, I can see everybody in Victoria who gets vaccinated and everybody with a blood clot to analyse the data more accurately than before. And the results from these investigations can either go to calming nerves if we don't find anything, or changing policy if we do, to help make sure that vaccines stay safe for everyone and continue to protect us against nasty diseases.
Thank you, Hannah, for nailing the last presentation. Well done. And judges, would you like to provide some questions?
So, this is fantastic for your state. When this is going to be live there, and maybe when it's going to come here as well, because it's very important for everyone to have this.
Yeah, absolutely. That's a great question. So we are currently already using it. So because it's such a massive platform to set up, we're doing it in multiple stages. And currently we have 7 out of our 9 expected data sets already linked. So we're already able to find side effects that are occurring in the hospital population and in the perinatal population. So this means that we're able to use it straight away, and we'll add more data sets as we can to find more and more things. And at the moment, it's just in Victoria, but we are looking at possibilities of collaborating with other states to make this more impactful across Australia.
I'm just going to ask what I'm sure a lot of people are thinking. How or do you even deal with the media and social media and the public and just regular people if they find out what you do?
Yes. And that's a really good question, and this is something that I am still learning myself. But the thing that I have learnt is that people have very rational fears. People may be scared about certain things, and it's not about denying them. It's about trying to put it in a context of the benefits versus the potential risks, which are, very, very minimal. So it's all about communicating the science, I personally stay out of anything more policy-driven than that, but I see my role as just communicating data as best I can and hope that people make the right decisions based on that. Thank you.
I'll just let you get those beautiful mind-like diagrams out of here. Beautiful. All right, didn't they do amazingly? They can hear us, they can hear us. I don't know about you, but I am so inspired about our future and about the people who are making it. So what's going to happen now is I am going to ask our 3 judges to retreat to the deliberation room to decide the winners for 2023 FameLab. And the judges will have 20 minutes to deliberate, and during the break, I invite you to rapidly refill your glasses at the bar and then come back and sit down quickly. All right, I'm looking at you guys, all right? All right, so yes, 15 minutes. I will come back. So off you go. I've been inspired, you've been inspired, and I'm sure we've all had some great conversations associated with the finalists' talks. But before we get to that all-exciting moment of the envelopes being opened, I would like to introduce the Honourable Minister Stephen Dawson to give a speech.
Thanks everybody and good evening. Can I start off by saying Nala Kadich Wajok Nyunga Murt Kayan Kedak Nijibuja. Can I acknowledge that we're in the land of the Wajok people of the Noongar Nation tonight and pay my respects to elders past, present and emerging. And my goodness, how amazing were those 12 finalists. Let's give them all a big round of applause. You know what, I reckon if I had any one of those at school, I'd be a scientist now and not a science minister. They're truly amazing. Can I acknowledge the judges too, because of course I am so glad that I'm not a judge tonight. You have a very difficult task ahead of you, so thank you for your questions and thank you for being part of tonight. What an amazing event. And can I acknowledge and thank the teams who've come to Western Australia from around Australia. We are incredibly proud to have FameLab in Western Australia, and I think Malcolm told me it's been going for a number of years. And I do just want to acknowledge the sponsors, but the people who have been behind this for a number of years. In particular, and I'll name a few people, can acknowledge Mr. Alec Coles, OBE, the CEO of the WA Museum, Boola Bardip. Can I acknowledge Corley Bishop, the CEO of the Foundation for the WA Museum. Can I acknowledge Mrs. Tonya McCusker, AM, from the McCusker Foundation, but of course, the Honourable Malcolm McCusker, who's here tonight as well. Can I acknowledge Megan Enders, who's here from the Fogarty Foundation, James from the Forest Research Foundation, and the team who are here from Curtin University, and I think we've got some people here from JETSI. The state government are very happy and very proud to support organisations like the WA Museum Foundation, who are doing great work to increase awareness of STEM and indeed STEM's value in our community. We are, as I said, delighted to have hosted the national final in Western Australia, and we've had it since the competition was introduced 4 years ago. Initiatives such as the FameLab play a really important role in building STEM culture and providing real-world role models that can connect and indeed inspire our community. Science underpins the diversification of our economy. It creates new and exciting industry sectors such as space or indeed life sciences or new energies. And we know that STEM skills will provide the solutions to environmental or health or indeed social challenges that we now face and that we will face into the future. So by supporting initiatives such as the FameLab, which empowers researchers with science communication skills, we can help bridge the gap between the lab and the public, ensuring the knowledge of our talented researchers can be used to its fullest potential. So again, to all of the finalists, can I say I appreciate the fantastic work that you've done tonight to communicate your really important research, and thank you for sharing your passion And with that, I now welcome to the stage Olly Bishop, who's the CEO for the Foundation of the WA Museum. Thank you.
Thank you. I'd first like to acknowledge the traditional owners on the land we gather today, and I pay my respects to elders past and present, and extend that respect to all First Nations people here today. Well, it's been a big night and a fantastic evening, and I'm very excited because I think I get the best job. I get to announce tonight's winner. The Foundation for the WA Museum has been the producer of FameLab in Australia for a number of years, and we're delighted to have FameLab back live in Perth. 2 weeks ago, the final of FameLab Academy, the student Year 8 and Year 9 version of FameLab, took place at Curtin University. The students didn't just present at a competition, but were able to explore a research expo and get some really hands-on science experience. Tonight we're here in the beautiful Hackett Hall under Otto the Whale, and the FameLab final isn't just being watched by the people here tonight, but also across the globe via our live stream. The Foundation for the WA Museum works to mobilise support for the museum, increase the cultural, scientific, educational and social impact of the WA Museum, and help secure its long-term financial stability and sustainability. Two of our key support areas for the museum are its research and fieldwork and its education, learning and outreach programs. And this is why we produce FameLab. It's such an important and powerful way to identify and nurture new voices in science. Through the program's training and masterclasses, FameLab participants can increase their science communication skills to help support their career, open doors for them, and get non-scientists interested and excited about the amazing work these researchers do. And the ability to get people excited about science is one thing they'll have in common with the WA Museum, who do this every single day. So congratulations to all of our finalists. I can't wait to see where your career takes you. We couldn't have run FameLab Australia without the support of our partners, and again, I just wish to thank Cheltenham Festivals in the UK, the Forest Research Foundation, Comet Communications, Curtin University, Murdoch University, the McCusker Charitable Foundation, Community Broadcasting Foundation, the West Australian Museum, and the WA Department of Jobs, Tourism, Science and Innovation. And also, please, a sincere thank you to our esteemed judges who have had a very, very difficult job tonight. This year, we received over 75 applications for FameLab across Australia, with 48 people competing in the semi-finals. From here, we selected our extraordinary 12 finalists. And the FameLab Australia winner will go on to represent Australia at the international finals run by Cheltenham Science Festivals UK in November. So let's look out for another rising superstar. All right, the moment's come. Let's welcome our finalists back to the stage. I think you guys are a hit. All right, here we go. Oof. Our first runner-up is Matt Shaw. Our second runner-up is Melissa Panini. I do, right? We need a drum roll machine. Ladies and gentlemen, and everyone else in our audience, our 2023 FameLab finalist winner is Olivia Carroll.
Wow, that's so exciting. Can we just congratulate all the finalists one more time? Wow, so much passion, so much pizzazz, and such great props. I just want to take this moment to congratulate and thank also the team behind this incredible event. They're in the background, and they have been making this happen. So Wayne Lubb, Nancy Hackett, and Ariane Bayer, can we have a round of applause for them as well? Come on, Nancy. And for everyone else who's hiding in the background, thank you so much for making this event possible. So, now, it's all of your turn, okay? Let's get out there. We have to make that technical knowledge known, all right? So, I just want to, two last things. The bar's going to stay open, so we're going to keep partying. But the one last thing is someone has misplaced a CPP parking ticket. So if you have parked there, can you just check that out so that you don't have to pay a big parking fine? So thank you and good night.